Hello, everyone, and welcome to MP Coding. If you're tuning in for the first time, a huge shout out to you. Grab a coffee, get comfy, because today marks the kickoff of something pretty exciting. I'm diving headfirst into a brand new video series all about Linux driver development using the Raspberry Pi. Yeah, you heard that right. We're talking everything from the absolute basics to some seriously advanced stuff that'll have you building custom kernel modules like a pro. Whether you're a hobbyist tinkering with hardware, a student grinding through embedded systems, or an engineer looking to level up your low-level Linux skills, this series is designed to take you there step by step. So what's the big picture here? Over the coming videos, we'll build a rock-solid foundation and then layer on the complexity, all hands-on with the Raspberry Pi because, let's face it, nothing beats that tiny powerhouse for prototyping real-world drivers without breaking the bank. We'll cover the tools you'll need right up front, point you to killer resources like the Linux Device Drivers book. 3rd edition is a must-read, and get your setup dialed in so you can follow along without a hitch. Kicking things off in Section 0, Introduction and Preparation, we'll start right here in this very video with a deep dive into what this whole series is about, the roadmap, the why behind it all, and how it fits into your learning journey. From there, we'll peel back the curtain on the Linux kernel itself. Think architecture, the divide between user space and kernel space, and why that matters for anyone writing drivers. And we'll wrap up this section with a solid overview of Linux device drivers, setting the stage for everything that follows. Jumping into Section 1, Raspberry Pi Setup and Development Environment, we'll get your hands dirty fast. First up, setting up your Pi. Installing the 64-bit Raspberry Pi OS, enabling SSH for remote work, grabbing those kernel headers, and deciding between native builds on the Pi or cross-compiling from your beefier desktop. I'll even share my go-to-directory layout to keep your projects organized. Then, in no time, you'll be loading your very first kernel module, a simple hello world in .ko form. We'll tackle the makefile, insmod and remod commands, modinfo for peeking inside, and those kernel print levels so you know when your code's actually talking back to you. By Section 2, Character Device Driver Foundations, we're rolling up our sleeves on the core stuff. We'll break down the basics, allocating major and minor numbers, initializing and adding your character device, handling manual make nod versus letting UDev do the heavy lifting, and a quick tour of file operations. Then we go deeper into those file operations, open and release, read and write, with all the gotchas around copy to user and copy from user, plus stashing your private data in the file struct. I/O controls get their spotlight next, defining commands, handling them in the driver, and even whipping up user space apps to test them out. We'll chat memory allocation to kmalloc, kzalloc, vmalloc, those GFP flags, and a nod to the slab allocator. And to tie it together, kernel-linked lists, how to work with list heads, iterate, add, and delete entries, perfect for managing data in your drivers. Section 3 shifts gears to GPIO, interrupts, and timers, because no Pi driver series would be complete without hardware interaction. We'll cover GPIO control from the ground up, requesting and releasing pins, setting and getting states, and even debouncing for those noisy buttons. Interrupts? Oh yeah, mapping IRQs, request IRQ calls, the whole top half versus bottom half dance, and choosing between tasklets and work queues for your deferred work. For timing precision, we'll explore high-resolution timers, one-shot versus periodic, with callback examples that'll have your driver ticking like clockwork. Moving on to Section 4, I2C and SPI drivers. We're talking communication protocols that power so much sensor and peripheral magic. Start with I2C basics. The architecture, clients versus adapters versus drivers, registering your I2C driver, and creating devices via sysfs. As a full example, we'll build out a complete BMP 180 sensor driver, reading and writing registers, handling calibration, pulling temperature and pressure data, and exposing it all to user space. SPI gets the same treatment. Its architecture, full duplex transfers, and those message and transfer structs to make data fly between your Pi and chips. Section 5 is all about concurrency and synchronization, because kernel code waits for no one, and neither should you. We'll spin up with kernel threads, cover best practices for loops, and stopping them gracefully. Wait queues, poll, and f-async come next for blocking and non-blocking I/O, implementing that .poll method and async notifications. Synchronization techniques, mutexes, spin locks, completions. We'll break down when to use which to avoid those nasty races. And for bottom halves, Work queues versus tasklets, system-wide versus dedicated, all compared head-to-head. In Section 6, Linux Device Model and sysfs, we level up to the bigger ecosystem. The device model, devices, drivers, buses, the probe and remove lifecycle, and events for hot plug magic. Sysfs interfaces are key here, creating attributes, managing files, and building those handy /sys/class entries for your driver. Plus, debugfs for runtime debugging. Entries for live variables, way different from sysfs, but also useful for troubleshooting. Section 7 dives into device tree and Raspberry Pi overlays, which is Raspberry-specific gold. Why device trees exist, their .dts and .dtsi structure, status, compatible, registers, GPIOs, all that jazz. Writing overlays, structure, dynamic nodes, applying them live. We'll do a GPIO example, LEDs and buttons in DT, binding to your driver, reading pins from it. Then an I2C device like the BMP180, custom compatibles, config via DT. Platform drivers as an optional but recommended detour for non-bus stuff, pin control, and muxing on Pi pins, and of parsing helpers for grabbing strings, integers, and GPIOs from the tree. Section 8 cranks it to advanced topics. Miscellaneous device drivers for quick/dev exposure when char devs feel overkill. RegMap API to streamline I2C and SPI register access. Caching, syncing, less boilerplate. DMA basics and MintP for offloading copies from the CPU, mapping APIs, simple examples. Safely accessing files from kernel space, filp_open, kernel read-write, with warnings, and a log to SD card demo. Memory mapping with map to share buffers user side, custom frame buffers, page faults. The IIO framework for ADC-like data, and sending signals to user space for event notifications, like IRQ-triggered pings to your app. Section 9 keeps it serial with UART drivers, Pi's UART setup, a minimal driver, and termios from user space for testing. Finally, Section 10 wraps with the final project, a beast of a driver pulling it all together. Device tree overlay, char device with I/O control, sysfs interface, GPIO interrupts and poll, high-resolution timers, optional I2C or SPI, debugfs vars, and a full user space tester. We'll even cover packaging, versioning, DKMS for easy installs, GitHub tips, and sharing as a module package. Phew, that's the roadmap, folks. Packed, practical, and paced so you can build as you watch. If this fires you up, hit that subscribe button, drop a like if you're ready to code, and comment below. What's your first Pi project ever? Stick around for the next video, explaining user space, kernel space, and hardware. See you in the next video.